Welcome to our This Is My Ride, Bike Stories by Argon 18 podcast series, where we match up our staff and professional athletes with their friends, mentors, competitors, and heroes for a conversation about training, living, racing, and enjoying the ride. Today, we're speaking with three members of Argon 18's R&D team about their roles in the development of the new E-119 Tri Plus disc. It starts now. So hello, everyone, and welcome. My name is Heather, and I'm part of Argon 18's marketing team, and I am chatting today with three members of our R&D team. So let's start with some introductions. Can you guys tell us a bit about who you are and what you do at Argon 18? We will start with, because he's first on my screen, we will start with Martin.
I am Martin Faubert. I'm VP of Product at Argon 18. Been with the team since 2009 already, so quite a long time. And mainly managing the development team and the product offering. Maybe Joffrey can go.
Yeah, I'll follow. Hello, I'm Joffrey Renaud. I'm a composite engineer at Argon 18, now in charge of quality. When we developed the 119, I was more part of the R&D as a composite engineer and part of research team as well. I'm at Argon 18 since 2017, if I'm not wrong. GF.
Yeah, my name is Jean-François Boivin, and I work as a mechanical engineer for Argon 18 for the last 3 years. So basically what I do is I take the intended bike definition that comes from product development, for instance, Martin, and I take all of this information and assist our industrial designer and then use SolidWorks to make the CAD model of the bike. Then we go in the 3D printing of the bike to make sure everything looks good and is compatible with the parts we wanted. And then I transfer all this information to the suppliers to make sure that everything is built according to our requirements. So that's basically my job.
Nice. Well, thank you, guys. Before we get specifically into the details on the bike, let's talk a little bit more about you and your background. So each of you obviously come from different background before you got to Argon. So can you tell us a little bit about that and what you bring to the roles that you have here? Let's go over to Joffrey first this time.
Okay, so I have an engineering diploma in France. Then I did a master and PhD in Polytechnic Montreal in mechanical engineering. I'm specialized in composite material manufacturing. And basically, Argon 18 was the first job I applied in, and I basically joined the company and stayed in for maybe 5 years. So that's my background. Maybe an interesting background for the project we'll talk today is that I do triathlon a lot as an athlete, as a coach in short and long distance. So it's something in the expertise I applied to this project.
Nice, thank you. Let's go to Martin.
So my background is industrial design. So before working with Argon, I was working as a design consultant. I've been involved with many different projects, appliances, medical tools, and other stuff like trains. And one of my last projects as a consultant was working with Argon 18. And shortly after, I joined officially the company as the first R&D dedicated staff. So I was in charge of about everything from drawing, 3D modeling, going to factory and doing QC and all that stuff. And it kind of grew up the team to up it is now. And so, yeah, I did it all a bit.
Cool. Let's go to Jean-François.
So as I said, I'm a mechanical engineer, and as long as I can remember, I always wanted to work in the bike industry. In fact, I became an engineer to make bikes. That was the goal.
So congratulations, you've done it.
Thanks. I remember being worried about career choices when I was a teenager, and my dad asked me what I really liked in life, and I said ride bikes and maybe invent bike stuff. And he basically told me that mechanical engineering was probably the way to go for me. So I went for it and never looked back, really.
So your dad was right, is the moral of the story.
Yeah, for sure he was. He saw what I wanted to accomplish.
Nice.
But however, I did not start my career in mechanical in the bike engineering. I started in small household appliances like a hair dryer and clothes irons, frère passé in French, epilators, and some of consumer products. And then I moved to electric car drive system, both for motors and inverters, which was very challenging in a technical way. All needed to be very precise and well thought out to work properly. So that was a good learning experience for me. Then my third job was to work in to design continuously variable transmission systems for tractors. It's like very complicated transmission systems, which is seamless. It's a bit hard to explain, but let's just say that those products were very complicated and there was lots of moving parts, and you had to have a very good understanding of all the mechanisms and things like that. So I finally got a chance to work at Argon 3 years ago, and we could say that bikes is like a simple stuff to work on compared to all the other things, but in fact it is not. It's not really. There's so much details to be worked on a bike, and there's also the aesthetic aspect to it that can be quite challenging for a technical engineer like me. But I think I made a good transition, and now I'm really happy to work on a Superbikes project.
Very nice. Great.
And I agree with Jean-François. I did my PhD in the aerospace industry, and sometimes we believe that the parts we're working on are maybe the most complex in the world, but designing a bike and manufacturing it is a big of a challenge. The stress that are implied on the structure are very complex, and you have to make a nice part that is also very structural, and it's sometimes very complex. And for a triathlon bike, you have after to integrate a lot of items in the bike, so it's a really challenging design.
Yeah, everything is interconnected. It's the most challenging part.
Nice. Well, speaking of interconnected, when we look at the development of the E-119, the new bike, how did you guys all work together? So how you obviously are coming from different backgrounds with very different roles, but how did you work together specifically on that project? Anyone can go first. Free
yeah, I can go. I think it all start by bringing new ideas, what we can do with that project, what were the main, let's say, innovation we wanted to bring and how we could achieve it. And I think Joffrey was one of the first person really involved in that project, because before going to a full-blown development, we started by creating a proof of concept of that integrated braking system. And this was quite a different challenge than before, because we used to work with, let's say, carbon and the frame and the forks but developing a new brake, even if it was based on the current braking system, we were developing a new brake, but also a new way to attach to the frame. And there was a lot of uncertainties related to this, the heat management, how we would fix, how we would adjust, and so on. So the first step was really to prove to at least the company first and the rest of the team that this crazy idea was doable. So that was really the first step, and on that, when we knew that we had really something workable, we start bringing like more people and trying to figure out, okay, the braking is cool, now let's move to the other part, the cockpit, the integrated toolkit, and so forth. So that's a bit how we started.
Yeah, maybe it's interesting to note that because of the integration of the brakes and how it generates heat, it's not, it can be seen as not compatible with the material we use. So there was a proof of concept to do, like Martin said, but the problem is that it's not easy to prototype composites if you don't have a mold. And basically doing a mold in our industry means that you go in production. So it was something we didn't do before because of this challenge. And we worked around and managed to do small molds in-house and do everything. We did kind of a Frankenstein based on the 119 rim brake fork just to prove that it works, and develop the brake around for our first prototype. And then it went into production with some modifications. But as Martin said, it was the first big step to show that it works, it won't melt the fork away, and and so on. And after it was more integrating. I was racing the 119 as an athlete for a while, and I had a lot of friends and athletes I knew with this bike, and it was easy to see what was good and bad in the bike, and we basically drew what we wanted to modify on the bike and what we wanted to keep. Integration of more food and some tools was a big point to me, and that's what we did on the bike, and that's how we went after. And maybe the cockpit was another topic, and maybe Jean-François can jump on this, but that were to me the three main topics on the bike.
Well, yeah, on my part, at first I took care of the brake design and the integration in collaboration with Joffrey. But just the brake part was some hard work. We had to develop the complete brake system with our partners, which is Tektro. Well, they provided some guidance, but the design was ours to define, both the front and rear caliper as well as the brake levers. So there was a lot to do. There was also the carbon structure to accept the integrated brakes that had to be done. Thanks to Joffrey for that, and all the suppliers worked on that as well with us. It took more than a few iterations to get the satisfactory design. I remember that the first caliper we made were eating a lot and did not perform very well. So it's a good thing we stayed true to our intentions and continued to work on it, because maybe it was not as good looking at first. And then I worked also on the door toolkit door mechanism with the help of from my colleagues. Again, there was many iterations of this aspect, and also the brake lever, shifter, and bike base bar grip integration was some other work to be added on top of all that. But fortunately, we had a very good teamwork, and Joffrey helped a lot with the cockpit design, which was made in collaboration with the 51 Speed Shop. So I had lots of work to do on the frame and brakes, and it's a good thing we had a couple of team colleagues to work on different aspects that we put it together in the last iteration. And so yeah, that has been a very good teamwork. I remember Joffrey going to Taiwan at Tektro to assist with the brake caliper testing while we were in China working with the carbon frame supplier to be able to get all this together on one cool bike. So it was a great adventure.
Yeah, because maybe what we need to keep in mind is that the brakes and the cockpit projects were two crazy ideas in the beginning. The brakes, we talked about it, and it was a crazy idea, and we worked a lot to make it true. The cockpit was a crazy idea by 51 Speed Shop. He submitted us several designs that we first tested in FEA. Maybe we didn't talk a lot about our colleague Pierre, but he's the FEA analyst, and he helps a lot in all the iterations, either it's in aluminum or in carbon. He basically can model everything on his computer and give us a good direction at first. And when we have something better, he will implement based on the results we have. For the brakes, for example, he also managed to draft a model on how it will cool down, so based on a CFD analysis. So even if it was not perfect, it was very good to help us give a new direction to the project. Or if you, for example, Jean-François told about cooling of the brakes in the very beginning. So what can we improve to this? Can we put a duct somewhere on the brake to conduct air inside while you are riding? It was all that kind of stuff that he helped us with. And for the cockpit, we basically wanted it more simple to use with less screws and so on. And it's a bit of a challenge because when you have many parts, it's easier to make everything strong, but not necessarily easy to adjust. And when you want to use less parts, you came in the shit, and it's harder to have everything work together. So we had basically the same thinking with that project, with small iterations. I remember, if I'm not wrong, Martin, we started very small with just the swivel adjustment, testing it at fatigue, choosing the right alloy to put on it. And then we had the basis of the mechanism, and then we went from this and drafted all the rest around. So it was a coupling of local machining, local testing with our machines, FEA, and after that, design implementation in partnership with Matt from 51 Speed Shop.
Yeah, it was great teamwork, for sure.
Nice. Well, we just talked about prototyping, design, collaboration with internal and external collaboration, and production. So sometimes it's hard for a rider or someone outside the company to understand how much time actually goes into this development process. Can you guys estimate how long it took you, or how much time it takes to develop a bike like this, a super bike, from start to finish?
But I think, if I remember well, fortunately we were able to start before COVID. So
True. True.
We started really working on it 2 and something years ago, like a bit, almost 2.5 years ago, starting the proof of concept of the braking system first. And and fortunately enough, we were able to do the main critical part of like early development and the first prototype, like before the COVID. So when we were kind of restricted from traveling abroad, and we were more in the industrialization phase. So opening molds for the other sizes and scaling up the production. Of course, this, like, we were able to do the major part before. The last year was struggling to get output from factories and getting the last mile done. So all the small steps that are crucial, the quality control, all the procedure for production, the instruction, the artwork, the painting, getting everything right up to our standard. It has been as difficult as developing the main concept and the main, like, let's say, the main engineering. because of restriction, because of the communication, because of all this getting more complicated.
And I think that's a good thing, because I don't see how we could do this now. Even having suppliers work that hard with us to develop new things.
Yeah.
Now
Wow.
the focus is on production. That's the only thing that matters.
Yeah.
For me, it was about I would say a year and a half of continuous work on SolidWorks for this bike, from initial brainstorms to actual pre-production versions. The amount of work was just insane. And there was so much decision to be made, so many details to check and confirm with our suppliers, and the 3D print, and there was plastic parts, carbon parts, machine parts, forge parts, all sorts of parts. And all, even the hydraulic channels inside the caliper had to be modelized, and this level of work had to be done by us. The Teco had insights for us, but we did have to make our own thing. I had to learn how in much details how brake system worked. And then there was the lever and the integration of the shifters as well on the base bar, which was also a puzzle as well. And on top of that, the one thing that generated a lot of work for me, but most people wouldn't know, is the integrated grips that comes with the base bar, that is integrated with the brake lever and the base bar and the shifters, and all the, even the texture on the rubber has been made by us. That has been, from a 3D modeling point of view, this was my biggest challenge to this day.
Wow, nice. Are there any other major challenges? I mean, we've touched on some of them, and I think we've also touched on COVID, which was obviously kind of threw a wrench into things. But are there any other major challenges or successes? What were the major challenges you were able to overcome during the design process?
From memory, I think we spent some time on what we call the bridge of the cockpit for the strength of this part. So we had at first the swivel that worked really quick, but after the issue is that there is no norm to test that kind of part. So we developed our own norms for that project based on what we had in the past. So we basically tested our own system and went until we managed to break them in fatigue or with very high static loads. But it's our internal norm, so we cannot say if it's too hard compared to the reality. It's really hard to define. And we broke a lot of parts during development. Even if the swivel was done, we still had to manage how we will clamp the extensions and what screw we'll put on this. And I remember it was a good challenge. It was a bit like developing a stem, but we spent a lot of time on the fatigue machine and in FEA.
Nice.
But for me, the biggest challenge, I think, was the integration of the rear caliper on the chainstay.
Okay.
The fork has like pretty big depth dimensions, so there's much more space for the caliper to be integrated in front. But then we had to make the same for the chainstay, and it was a real challenge to come up with something that would look good, that would perform good, and that would be strong enough, and that would look alike the front part of the bike. I think I did something like 12 iterations of rear design, and
Nice.
we ended up with something very nice, I think, with the rear brake cover, which directs some airflow inside the caliper to keep it cool and to have some more aero performance. But there was a lot of iterations, and it did not really come like easily. There was a lot of discussions and brainstorms, and we finally got it. But it was a long time working on that, and I remember sometimes being a bit worried that it would not look as good as I wanted, but finally we did it. So for me, it was very
Rewarding.
like rewarding. Yeah, exactly.
Nice. Good.
Maybe Martin, you remember about the toolkit? We spent some time in pre-project defining where we're gonna put this toolkit, and we went, I think, everywhere on the bike to finally decide to do what we did. But remember, you submitted tons of ideas, and we tried them, but it was hard in the beginning.
Yeah, true. But it's part of the process of trying and see what works, what's not. And I think the worst project are the one that are too easy and where you just take decision without really trying and trying other, because if you just go for the first solution you have, you might be in like, maybe not getting an error, but not figuring out the best way to do it.
Mm-hmm. Yeah.
Experimentation is the best, always the best way to go. And 3D printing has helped us a lot with that in the last couple of years, like let's say the last 5 years. Before that, it was really hard to get physical prototype. Like we had to machine parts, or it was very expensive, very complicated. And now with 3D printing, it's so easy that you end up your day doing your CAD, you print it almost overnight sometime, and next morning you're ready to, like, you have a physical prototype, you can play with it. And before we were spending months on, like, inside the computer on CAD design, not knowing exactly the real proportion, the real function, how it works, and so forth.
Mm-hmm. Neat.
Yeah, maybe the good thing to tell is that we have different printers. One that allows to print a full-size frame. So basically, it really helps Jean-François or everybody in the team to validate a physical part. And sometimes for very critical part where the dimension or the shape are need to be very precise, we also have dedicated machines that will be really precise, and we managed to go very far and very deep in the details before to open a mold for plastic parts, for example. And it's a very great help, because otherwise, if you don't have this, you have to open a mold, test the part. There are long waiting times between those two steps, and you lose a lot of time. And so we worked a lot with 3D printing, especially for that project.
Nice. Well, we've talked a lot about the features and the process, but have you guys ridden the bike? Have you gotten to ride the bike, and how does it feel?
Yeah, Joffrey, you can go. You're probably the one who has spent the most time on it.
That's fantastic.
This one's for you.
How do these features feel in real life?
I remember with Jean-François, we spent a morning on the Circuit Gilles Villeneuve in Montreal, giving the bike to Jean-François, taking it back and trying stuff. But yeah, I spent a lot of time on it, because basically I raced a lot, as I said, the 119 rim, and I also raced the 117, the 118, but I always felt home on the 119, because that's a fit that I like a lot. And I stopped using the 119 rim when we developed the 117 and 118, because there were disc brakes. And I finally felt home again when I started using the 119 disc, because of this fit I like a lot, and also because we tweaked the cockpit, to me, very well. So yeah, I raced it a lot, and I didn't race it a lot because of COVID, of course, but I used it around home for validation, and also on the track when we did some aerodynamic testing afterwards.
Nice.
But basically, if I have to sum up what I feel on that bike, to me, it feels like the 119 rim. It's as good as this bike, but you have disc brakes and a way better integration. And if you need to play on your feet position, you can do it very, very fast compared to what we had before. So for most of the triathletes, I think it's a good point.
Nice. Well, we just mentioned the E-117, the E-118, and the E-119. So Argon 18 has a couple of super bikes in its lineup. And could you explain a little bit about the differences between those bikes, or some of the strengths of each of them, and how the new E-119 fits into that family?
Yeah, I can go. Well, let's start with the 117. So this is, it's probably on one side, the most affordable bike. It's our first price point in our lineup. But it's not just about price. It's also about the fit that bike can offer, because it's a more, not a proprietary cockpit. You can use whatever stem you want. You want to flip the stem, you want to put this specific cockpit part or extension kits, or it's really open to, so it has a bit of broader fit window because of the 3D system, also because of the stem steerer, classic stem and steerer. Because of all those points, you can really find your fit on that bike. It's also a bike that it's easier to travel, because they are all known part. There's nothing very fancy with that setup. It's a UCI legal frame, so you can do UCI TT, you can do triathlon, long, short distance. It's a very simple bike to maintain also. So this makes the 117 a very, very good value and performance package. And then we have the 119. 118 was developed specifically for Astana, so a more, let's say, TT focus frame set. The fit window is more aggressive than 117, more aggressive than 119. Really focusing on going fast, hard, maybe a shorter period of time. But it's a great bike also for shorter riders that are looking for a lower stack. So UCI legal. So again, you can do both UCIL TT and of course triathlon. And the 119 was really meant to be the ultimate machine for long distance triathlon. So all the technology you can get and all the integration also. So if you want a really, really clean looking bike, because the toolkit is integrated, the food is integrated, it's really a complete solution for triathlete.
Nice. You guys have anything to add?
I would not say better.
If I may, I would like to follow up on the previous question that Joffrey answered about what we felt when we first rode the new E-119.
Yeah.
So I went with Joffrey to Circuit Villeneuve, and I was very impressed at how efficient the bike is. You don't really need much power to go pretty fast, but I'm more of a mountain bike rider, so for sure any road bike is super efficient for me, but this one really standed out from the others I've ridden.
Nice.
But then when you're going fast, you do have a lot of power to slow down, and that's what was impressing me a lot on this bike.
Nice.
Brake power, I know what I'm talking about, and thanks to the disc brakes, I think they are very powerful and precise for 140 millimeters rotors. At first, I was a bit doubtful about the performance we could get out of such small rotors, but I think we did a great job with Tektro. The calipers are really stiff, and the brake pad material is on top, so the feeling is really good, and you can really stop on a dime. It's very impressive. Even on Mont Royal, going down going down the mountain, you can really have confidence on the brakes, and I was really impressed with that. And
So for a mountain biker, you're okay with this?
Yeah, for sure.
Nice.
I approve the brake power,
Excellent.
without any problem.
Excellent.
There's another feature I wanted to talk about that I think really stands out, but in fact we don't see it really much. So I wanted to talk about it. It's about the shifter integration, especially on the SRAM ETAP build. We had the shifters right on top of the brake levers, so you can barely see they're there. You just have the button at your thumb, and you cannot see anything else. And the cable routing goes inside, and the dip box is snugly fit inside the stem cap. So it really makes for a great looking bike, and you have all the features. And so this, I think, should be noted as well.
Nice.
Yeah, I would jump on this, maybe doing the link with the brake power. We had lots of criticism on the 119 because we did a flat base bar, and when you brake hard, sometimes you feel like you can fall off your bike because your hands are sliding on the base bar. And there was a challenge with the ergonomics of the existing solutions for disc brakes on TT. Basically, they go deep in your hands, it's painful, and it's not ergonomic. So that was why we decided to put all the hydraulics inside the base bar. But Jean-François did a very great job in ergonomics to have the base bar feel secure, and you can brake very hard, and there is like something to retain your hand that helps a lot. It's still nice to see, and it's not a big chunk in the frontal area of the bike. So there is a good integration, but also good ergonomics that was done on this project.
So it sounds like all the features that you guys are talking about, they're really detail oriented, obviously, and really focused on what a rider will feel. Like really the performance oriented rider is going to notice all of these details. So have you received any feedback from athletes who have ridden the bike about these types of details, like even the nutrition and the toolbox and things like that?
Maybe before the athletes, there was many comments about because people maybe are a bit scared of custom brakes. How do they work? Are they easy to assemble, and so on? And there were lots of feedback of mechanics or even athletes who assembled their bikes themselves. So we are talking obviously about professional athletes. They got their bikes before. And they told us it's surprisingly easy to assemble all the brake set in the frame. It basically works like a flat mount. It's really flat, so it's easy to assemble and adjust. And they were surprised that it was not harder than that to make it work. So to us, it's of course we spend a lot of time on this, and sometimes it's not seen by the customer, but it's nice to hear that it really is in the end. So
nice.
That was one of the feedback about the brake system. Maybe Martin, you had some other feedback from athletes?
Yeah, unfortunately, we did not have a huge quantity of bike on the market. We're still waiting for the first mass shipment. Unfortunately, the COVID has really made things complicated with supply chain, but it's coming, and it will be soon in shops. But we are working with a few athletes. Sam Long, we're working with Heather Jackson, we're working with our Danish athlete.
Also Eric Lagerstrom.
Yeah, exactly.
Yeah. And Michel Vesterby.
Michel Vesterby, exactly. Yeah. And they all fell in love with the bike. I think there's, of course, there was some aerodynamic gains from looking at the pure performance, but you said it, there was a lot of ergonomy thoughts on how the rider will feel during the race, and making things easier also for them. And it's hard to quantify how much you win and how much seconds you will gain. But I think not worrying before a race is really key. If you know that putting your bike to, like, getting to that Ironman race and putting your bike together is easy, you won't stress, and that peace of mind, I think, is very important before a race. And like knowing that your toolkit won't fall on the street while riding, knowing that you won't, you have a good grip while you will do that critical braking, like avoiding an incident, or so. All those things are hard to say you will win 10 seconds on a race. No, it's not. But at the end, it makes a great bikes. And I think this is the feedback we got from the athletes, is they really feel that it's a better bike.
Nice.
Yeah, and I did not talk directly to our sponsored athletes, but I did have a look at Sam Long's YouTube videos, and in this he says he feels that the new E-119 is faster than the E-118 he had last year. So he says with the same power he can go faster. So we don't know where this exactly comes from, but there's all the complete kit. He says that he really likes his fit, that he was able to adjust it perfectly to his liking.
Nice.
And then he says he really likes the disc brakes without the aero disadvantage. So that works in our favor as well. And I would like to quote him. He says, "It's the best triathlon bike in the world right now." So I'm very proud of that.
And we
You
believe
can
in
go
it.
look it up on YouTube. He says that. So I guess he had a good results this race season. So I expect he will continue to do well, and I hope we have a lot of other good comments like that in the future.
Nice. Okay, last question. Based on all this feedback and what you guys have said about working together and the challenges during this process, what are you going to bring to the next project? What do you think you're going to apply to what's coming next?
From the 119, you mean?
Yeah.
I think the level of integration we achieve with the 119 is something that I would like to see on other bikes or other more normal road bikes. And yet we're not done with it. I must say. No, I think it really changed the outlook of the bikes and how and we can definitely with what we have learned from that project, we can bring some cool stuff on other bikes.
Yeah, basically, a designer will always tell that when he finishes something, he already see how it could be better next time.
Yes.
I think both Jean-François and I know that we could do better calipers, for example, slimmer, something better. But so that's something we would do. But if I have something I would do again, it's more about philosophy. But it was the best teamwork I ever did on a project, and it was I enjoyed it a lot on a daily basis. It was really cool to have such a good fusion between the designers, the engineers, and all the guys internally. So I would do it tomorrow without hesitation.
Nice.
Yeah, well, I'd like to follow up on that. I think we learned as a team that we must not underestimate what can be done when we have time and a good team. I believe we did better than what we had envisioned in the early project, and that's a good thing. We had ideas along the way that we had the courage to get our ideas done until the end and not let good ideas along the way. So I think this was a very good thing, and we learned that we can innovate in this world, since there was a lot of things done in the bike industry, but I think we did some a world first with the brakes integration. No one has done something quite like that, and I'm pretty sure some others company will follow us in the next few years, but we are still learning from that, and maybe keeping some ideas for new projects in the future as well. So there's a lot to be done still.
Nice, good. Well, we have a lot to look forward to then.
Yeah.
We hope. Well, thank you guys so much for taking us behind the scenes with the new E-119 Tri-Plus disc. We'll look forward to seeing it out on the roads and the races in the next season. Thanks again.
Thank you.
Thanks a lot.